This is the Convair 880 commercial jet airliner. More than 4 years have been devoted to developing and proving the 880 to make it the finest and safest modern jet transport possible. From 880 assembly lines now producing on a regular production schedule, 4 880 aircraft were specifically assigned to the test programs. 3 of these aircraft have been flying on regular test schedules. The other was assigned to ground tests here in the structural test facility. Its task was to demonstrate 880 ability to withstand the maximum flight loads it was designed to take. Rigged in these elaborate whiffletree arrangements, the aircraft was deliberately twisted and bent in a series of instrumented tests. Tests that were designed specifically to explore maximum design loads in a program that simulated all operational extremes of flight through all types of weather. During these investigations, hard landings were simulated up to design limit loads. Engine pods and pylons were tested to extremes to simulate side gust loading, such as would be encountered in rough, stormy air. The fuselage was pressurized and deliberately deflected with massive loads to prove its ability to withstand forces that might be encountered during a pullout, such as would result from an abnormally steep dive. Typical of the tests conducted on the aircraft were those accomplished in the vertical tail areas. Diametrically opposed loads were used in a torsion test that applied maximum loads to the vertical fin in one constant direction, while at the same time, opposite loads were applied to the rudder. A test that explored strains that could be encountered during an engine-out condition. In tail fin bending tests, loads of up to 32,000 pounds were used to bend the vertical fin 15 inches off-center. A test designed to simulate maximum side gust loading conditions. Critical wing deflection tests were undertaken to simulate maximum wing loading, like the strains that could be encountered in a severe stall or pull-out maneuver. During this test, the wings were deflected as much as 6 feet, with loads ranging as high as 160,000 pounds. Downward deflection of the nose area was in excess of 1 inch, with over 43,000 pounds of load in this area. Aft section loading was 100,000 pounds, with a total downward deflection on the section of only 8 inches. There are these maximum loads with no problems encountered. In each phase of the test program, the airplane was fully instrumented and results recorded for complete evaluation. The aircraft was engineered to exceed these test limits by 1.5 times the maximum design loads applied without sustaining any major structural failure. On assembly lines now producing 880s for delivery to airlines, an 880 was constructed to undergo an exhaustive fatigue cycling demonstration. It was installed in a special tank measuring 110 feet long by 20 feet wide. When filled to capacity for the test, the tank contains nearly 400,000 gallons of fresh water. In the investigation currently in progress and scheduled to cover more than a year, the fuselage will be continuously cycled underwater in a test that will simulate more than 20 years of first-line service operation. A system of hydraulic actuators are used to apply the strains that would be encountered during actual ground or in-flight operation of the aircraft. The fuselage was constructed complete with stub wings. Addition of the wings permitted full-scale examination of the fuselage, including strains produced in the wing root area. This is the first time that the combined fuselage and wing section of a commercial jet aircraft have been fatigue tested this extensively in the United States. The test is being run on a weekly basis. Approximately 5,000 cycles are completed each week. The tank is then drained for a thorough inspection and refilled for continuation of testing. Control of the test and recording of data is done in a structure adjacent to the tank. Here, through an electronic time-controlled cycle program, the fuselage is automatically put through a complete landing, taxi, and flight cycle each minute. Each 1 minute cycle simulates 1 hour of actual flight time. During the cycle, the fuselage is pressurized from 0 to 8.6 pounds per square inch internal pressure, well in excess of maximum in-flight operation pressures, and then back to 0 again. Stresses applied to the aircraft during various stages of cycling range from 1.22 to 1.85 times the pull of gravity. Daily inspections are made by specially trained crews of divers to ensure that no trouble could go undetected at any time. As a result of these tests, airlines purchasing the 880 will be furnished with inspection manuals that will contain information on the tests and serve as a guide for routine inspections for the life of the aircraft, in addition to ensuring that the aircraft will maintain its airworthiness serviceability through a full first-line lifespan of 20 years.